What do you mean by the electrode potential? We have seen last class. The electrode potential of any electrode depends upon three parameters. What are they? The nature of the electrode. What is the metal or non-metal used for the purpose, nature of the electrode. Two, the concentration of the electrolytes in which the metal electrode is dipped, concentration of the electrolyte. Third, the temperature at which the electrodes are operating. These three things are very, very essential to determine the electrode potential. Some physical parameters depending upon various conditions. It is customary to introduce a standard condition. Here we are introducing the standard conditions. What are the standard conditions? And the standard conditions are implied not for the nature of the electrolyte, but for the concentration of the electrolyte. The concentration of the electrolyte is taken to be 1 molar. The hydrogen electrode is there. Hydrogen gas is passed through the H plus ion. Here the concentration of hydrogen should be 1 molar. And here the hydrogen gas is passed. And here you have to mention if whenever gas is passed, the standard is, the condition is, the pressure of the gas is 1 atmosphere. If zinc is dipped in a zinc sulfate solution, there is no condition for the solid zinc, but there is a standard condition for the zinc sulfate electrolyte, 1 molar. If it is gases, the pressure of the gas should be 1 atmosphere. Chlorine gas is passed through chloride ion. What are the standard conditions? The chlorine gas pressure should be 1 atmosphere. And the chloride ion concentration should be 1 molar. This is a standard condition. And the temperature is fixed to be 25 degrees centigrade, or it is 278 degree, 278 degree Kelvin. And whenever we represent the electrode potential data in terms of these conditions, electrolyte concentration as well as the temperature, we call that electrode potential as the standard electrode potential. To represent the standard condition, yeah.
278 Kelvin.
Hello?
Sir. 25 degrees
sorry,
Celsius.
298. Sorry, thank you very much. Okay, 298 degree Kelvin. And these two conditions, the concentration of the electrolyte and the temperature are maintained. Then if you express the electrode potential value, we call that electrode potential value as epsilon naught, epsilon 0. And the 0 indicates the standard condition. Therefore, for anything, it is represented as epsilon naught. And for non-standard condition or unstandard condition, that is other than if temperature, either temperature is changed, it is called a unstandard condition or non-standard condition. Or electrolyte is changed, concentration change, once again it is called a non-standard condition. If both are changed, once again it is a non-standard condition. Any one of the parameters change is called non-standard. In such cases, we represent the electrode potential simply by epsilon. Now, in the electrode potential table, every book would furnish this electrode potential table. They will give only the electrode potential under standard condition. Under standard condition. That electrode potential value given in that table will be either majority case it would be the reduction potential value. Reduction potential value, majority books. Only in small, certain dose, it will be given in terms of oxidation potential values. And I have already told you that in American convention, we are using the standard oxidation potential as well as the reduction potential. It is a bivariant quantity. These two quantities for a given electrode would be magnetically same, but according to sign, they are reversed. But according to European convention, whether you write is oxidation reaction or reduction reaction, they call it as the electrode potential. That indicates only reduction potential. And what is the convention we are going to now use is we are going to use only the oxidation potential. Here, if you convert all the potential into the oxidation, but all the electrode potential into the oxidation potential, there will be much advantages would be there. So to see, looking at the potential value, we can come to the properties of certain metal electrodes. Comparing the properties of the electrodes, we can say it is a strong reducing agent. It reduces these species, and it is a strong oxidizing agent, and it will oxidize these species. And this metal can displace this ion from its salt solution, etc. can be seen. But all other way also reduction potential value, if all them are given in terms of reduction potential value, it is also possible, but only is a practice. And here I am going to give in terms of the oxidation potential value. Whether they have given in terms of oxidation potential or reduction potential, I will first convert them into the oxidation potential value. Then I will try to give answer for the problems. And the next thing is, what is the unit given for this electrode potential? The unit given for this electrode potential is volt, in honor of the scientist Volt. And if you write volt in total inverse, you should use the volt V small letter. And if you abbreviate this volt, it should be in capital letter. Here you should not write it in capital letter. If you write it in the capital letter full form, it indicates the name of the scientist, not the unit for this. It's a customary. Therefore, volt, what is volt? What is the relationship between the volt and volt and the one? There is a definition for the volt. If you want to take this. If 1 joule of work is done, 1 joule of work is done against electric field, against the electric field, to bring 1 coulomb charge, 1 coulomb charge from infinity to the point in the electric field. The charge should be brought from infinity to the point inside the electric field. Then the potential difference at that point is called 1 volt. The potential difference at that point is called 1 volt. And you remember this relationship, 1 joule per coulomb. This is the relationship. It will be very useful to convert the volt into joule, or simply 1 coulomb volt. 1 coulomb volt is equal to 1 joule. Bring this coulomb in the opposite direction. 1 coulomb volt is equal to 1 joule. We are going to make use of this relationship. Therefore, volt, here you are indicating that epsilon oxidation potential value of zinc electrode is 0.76 volt means it indicates for the release of, that is for the one positive charge or one negative charge, this volt is represented For one charge, it is represented. That is for the release of one electron only. But the equation involves zinc, giving zinc 2 plus 2 electron. 2 electron. What is the epsilon value? It is given as 0.76. What does that mean? The electrode potential value is 0.76 volt per release of one electron only. Though 2 electrons are involved, here according to the definition of the word, to bring one charge from infinity to the point in electrostatic field. Therefore, here epsilon zero value is indicated by the release of one electron. Similarly, aluminium giving aluminium 3 plus, though it releases 3 electrons, the epsilon value 0.66 volt is for the release of one electron only. Whatever may be the number of electrons involved in that process. For I want another thing. 10 mole of aluminum I have taken. It releases 10 aluminum ion and 30 electron. What is epsilon naught? What is this standard electrode potential? Once again, it is 0.66 volt. It will not be multiplied or anything because this is for the per one electron. Whatever may be the quantity of aluminum you have taken, instead of 10 volt, 0.5 aluminum you have taken. Once again, what is epsilon value? It is 0.66 volt. That is, if it releases one electron, so much potential difference would be there. Therefore, this epsilon zero value, it is not depending upon the mass that is present in the equation or mole that is present in the equation. Therefore, we call such properties as intensive property. You might have studied in the colligative properties, intensive and extensive properties. What physical parameters are called intensive properties? Those physical parameters which are independent of the mass of the substance are called the intensive property. For example, what is the boiling point of water? If I am asking you, I will tell that 100 degrees centigrade. If you take 5 ml of water, the boiling point is 100 degrees centigrade. If you take 5 liters of water, then also it's a boiling point is 100 degrees centigrade. The physical parameter is now independent of the amount of the substance you have taken. Therefore, such properties are called the intensive property. So is the case with the epsilon zero. It is an intensive property. But delta G, from which we are going to the epsilon zero, we are going to calculate delta G. It is not an intensive property. It's an extensive property. What do you mean the extensive property? Those parameters which depend, physical parameter which depends upon the mass. Easiest example is the volume. If you take 5 grams of water, the volume is one thing. If you take 500 grams of water, the volume would be changed. This is called the extensive property. It depends upon the mass of the substances. Here epsilon naught. So is the case with the E naught, that is cell EMF. It is also, you are going to calculate in the application, you are going to see in the application of this electrode potential. Here also E naught, that is cell voltage, is once again an intensive property. That is for the release of one electron. With that, we will go to the calculation of the electrode potential. The electrode potential, standard electrode potential, is it easy to calculate for any electrode directly? Now, it is impossible to calculate the standard electrode potential for any electrode present in the bulb. Then how the tables of electrode potentials are given by comparing its electrode potential value with the standard hydrogen electrode potential. See, what is standard hydrogen electrodes? Here the hydrogen electrode is nothing but passing hydrogen gas. You should be in the standard condition. Standard condition is the gas, therefore, in 1 atmosphere, passing through the, it's the electrolyte. What is the electrolyte? H plus ion. its concentration should be 1 molar. The gas is having no electrical contact, solid electrode, therefore we are using platinum. It is called the SHIELD, standard hydrogen electrode. Actually, it is having its own potential, but we don't know the potential of this any electrode. But if you make an assumption that this electrode is having this value, then only the then only the electrode potential, standard electrode potential, or other electrodes can be calculated. Otherwise, it is impossible. For that case, the standard hydrogen electrode, the epsilon value, that is here I am going to write only the oxidation potential. That is indicated by means of this hydrogen bar H plus. That indicates hydrogen in the reactant side, H plus in the product side. Their oxidation is taking place. Therefore, the potential value indicated would be the oxidation potential. Here, the oxidation potential is taken to be zero for our convenience. Now, taking this potential as the standard, you're measuring the electrode potential. It is easier to measure this one. How? You have to find out coupling this electrode with another electrode. You have to find out a cell, and from the cell, say the cell value, you can calculate the potential of any electrode. For example, a cell is made up of this metal bar Mn plus time. The value is 1.1 volt, let us assume. And it is coupled by a metal and a hydrogen as such. Here we have taken it as zero. And what is the value of the standard electrode potential? It can be easily calculated. How would you measure this E naught value? That is the cell difference, or the cell potential by making use of the voltmeter. You can measure this 1.1 volt. Therefore, the X is said to be having 1.1 volt. Now the 1.1 volt is here, not the actual value of that metal electrode. If you take a hydrogen electrode as zero, its potential is 1.1. Therefore, the potential electrode potential value given in the table are not the absolute value. That is not the actual value. It is a relative value. What is the difference between absolute and relative value? Absolute means,
Sir,
yeah,
sir, for hydrogen you have given the reduction potential as 0, and for
yeah.
metal you have given oxidation potential as X.
I have already told you what I have already told you that for a given system, the oxidation potential and the reduction potential are magnitudically same. Only sign is different. For zero, if you plug plus zero and minus zero, both are same. Therefore, I place this like this. Okay?
Yes, sir. Thank you, sir.
Okay. In the case of, for example, now we have calculated this potential value for this. It's oxidation potential. What would be its reduction potential value? If anybody asks, you can say that its reduction potential is minus 1.1 volt. Here, if it is plus, the other potential is just sign, reverse the sign, you will get the value. And making use of this standard hydrogen electrode as the sun, what is the relationship between what is the difference between the relative value and absolute value? Absolute value is the actual value present. For example, how many of the students now participated in this webinar? Now you can say 53. It is the actual value. You are not taking any scale and then counting them. You are integrating the actual value. What is your height of Lingatona? And I am 60 centimeter height, sir. 1 centimeter is equal to how much? Whether it's a small this or it's a larger one. If you keep the centimeter is very large, your length would be height would not be 60. It's less than 60. Therefore, with respect to a scale, you are measuring another parameter, it is called a relative. Therefore, here epsilon value is calculated relative to standard hydrogen electrode. Take assuming that it is having zero electrode potential, but it will be having a definite value. Who knows it? God alone knows it. Until God will come and tell, until we will have a relative electrode potential value. Then some of the electrode relative potential value I am going to give. It will be useful for you to work out some problem in this table. In this table, epsilon naught table, I am going to give only the oxidation potential value. The highest oxidation potential value provided is the lithium and lithium bar lithium ion 3.05 volt. Then sodium bar sodium plus 2.74. Then potassium bar potassium plus 2.9 volt. Rubidium bar rubidium plus 2.94 volt. From this, you can tell the periodicity of this electrode potential. The periodicity of this electrode potential along the periodicity means along the column, how the potential varies. And along the period, that is along the group, how it varies, along the period, how it is varies. If you see this lithium, sodium, potassium, rubidium are belonging to the same first group, you see except lithium, all other ions potentials are going on increasing. And it is the correct one in a group. The potential, electrode potential is going on increasing. For example, if you take the second group, what are the elements present in the second group? Beryllium, next magnesium, next calcium, and next strontium, and then barium, which would be having higher oxidation potential value. Here I am mentioning once again repeatedly oxidation potential value. Oxidation potential is going on increasing. If you are asked to give, what about the reduction potential value along the group? It's going on decreasing. Just invert the wording. Here I am talking only to the oxidation potential value. But here there is an exception in the case of lithium. Why this 3.05 is higher than this one? 1 hour per cycle, you go and apply for this lattice energy calculation, you will have this answer. This electrode potential value of lithium or lithium plus it should be less than that for sodium. We should be lesser than 2.74, but it is 3.05. Why? தேடுங்கள் கிடைக்கப்படும். தேடி பாருங்க, அதுவும் சொல்லிட்டேன். Lattice energy calculation, you see, go and see this. And then some of them is chromium bar, chromium 3 plus 0.74 volt, and magnesium bar, sorry, I have written wrongly. Magnesium bar, magnesium 2 plus 2.74. Aluminium bar, aluminium 3 plus, it is 1.66 volt. Then iron bar, iron 2 plus, iron bar, iron 2 plus 0.44 volt. Hydrogen bar, hydrogen plus, this is we have taken is to be 0, and below hydrogen you are having still we are having some metal ions, and I will write it here. Copper bar, copper 2 plus value is minus 0.34. After the below the hydrogen electrodes, they are all having negative values for the oxidation and potential. Then O2 bar, O2, sorry, O2 minus bar O, this is the oxidation potential, minus 4 in acidic medium. Then copper bar, this one copper bar, copper 2 plus. This copper bar copper plus minus 0.52 volt. Iodide bar iodine minus 0.54 volt. Minus 0.54 volt. Iron 2 plus bar iron 3 plus is equal to minus 0.77 volt. Silver bar silver plus minus 0.8 volt. Bromide bar bromine, it is minus 1.06 volt. Chloride bar chlorine, all of them are oxidation potential, make a note of it, minus 1.34 volt. Gold bar gold plus equal to minus 1.68 volt. Then fluoride for fluorine equal to minus 2.86 volt. And in this table, the oxidation potential table, lithium would be in the top level and fluorine would be in the lowest level. And of these, majority of the questions can be asked making use of this electrode potential. Here, one thing, once again, the potential values are given for the release of one electron only, not the number of entire electrons. For example, and copper bar copper 2 plus means it releases 2 electrons, not for the release of 2 electrons, the potential is not minus 0.34, it is for 1 electron. Therefore, we can compare these epsilon 0 values for all electrodes because they are all for the release of 1 electron. And what does it mean? Lithium bar lithium plus is having higher positive oxidation potential, means it has a higher tendency to release electron immediately. Because right down the electrode reaction, lithium giving lithium plus electron. And its value is positive. Its value is positive means delta G is equal to, we are shortly going to use this equation. NF E naught. E is positive means delta G would be negative. What delta G is negative means spontaneous. You have studied. Therefore, in this section, the lithium bar lithium 2 plus has the highest tendency to release 3.05. Sodium and rhodium plus, it has less tendency to release electron compared to lithium and lithium plus. Potassium, it is less tendency than lithium, but higher tendency than sodium. So you can easily say this one. In short, compared to the C, that is standard hydrogen electrode, the metals placed above the standard electrode potential in the oxidation potential table are all having the strong releasing tendency of electron, and they will all acting as a reducing agents compared to hydrogen. Now you are given two things. For example, potassium for potassium plus, rubidium for rubidium plus, which is a strong reducing agent among these two. These two are reducing agent, but which is a better reducing agent? Those which is having higher potential, say oxidation potential. Higher the oxidation potential, higher would be the reducing character. Higher would be the reducing character. We are going to see shortly some problems based upon this one. Similarly, in the table, the least reducing agent is fluorine. F minus giving power of this fluorine. And you can reverse this. If it is the least reducing agent, it means it is the highest oxidizing agent. Therefore, which is having highest oxidation character, arrange the, yeah. Anybody?
Fluorine.
Oh, fluorine. Anybody, if you should arrange that, whatever may be the electrode potential given, you will be given not either all them in the oxidation sense or not on the reducing sense. They will just mixing both the oxidizing character potential and the reduction character potential. Therefore, don't confuse with this. Your main aim is whatever may be the oxidation potential given, you just convert it to the oxidation potential because we are taking practice only in terms of the oxidation potential. If you have already studied in the case of reduction potential, you keep it alone as such. But here, if you are not studied like that, you convert all the potential into the oxidation potential. Therefore, which will be the highest reducing character, highest positive oxidation potential, which metal is there? It is having highest reducing character. And which is having highest oxidation potential, which is more negative potential, which is having more negative oxidation potential. It is the oxidation potential. For oxidizing character is more. Okay. And another important property that is studied, those metals present above this sheet, that is standard hydrogen electrode, will release hydrogen from acid. They have the tendency to release hydrogen. They would reduce H plus to hydrogen. How I can tell this is I will give a small diagram like this. For example, Na bar Na plus is equal to 2.74. Aluminium bar aluminium 3 plus is equal to 1.66 volt. Then chromium bar chromium 3 plus equal to 0.74 volt. And iron bar iron 2 plus is equal to 0.4 volt volt. Now you are given like this. And among this, which is the best reducing agent, tell me, or now immediately you can say, highest oxidation potential, better reducing agent. Therefore, it is sodium, which is the least reducing agent. It is the lowest among the given set, lowest oxidation potential, which is having lowest oxidation potential, which is having lowest. Among the four, which is the better oxidizing agent, the lowest oxidation potential would be the better oxidizing agent. Therefore, among these four, iron is the better oxidizing agent. How to see this one, Adina? Here, if you go like this, iron and sodium to Na plus, it is a reducing agent. It is moving downwards, reducing agent. It reduces sodium, reacts with the aluminium to give back. Aluminium would be converted to aluminium 3 plus would be converted to aluminium. Therefore, sodium can reduce chromium 3 plus. Chromium can be reduced to chromium. Sodium can reduce iron 2 plus. Iron can be converted to iron. Okay, this is the same property. The same reducing character is going to be used. Which metal will displace which ion from its solution? The same reduction character is used. If you add a piece of sodium into an aluminum sulfate solution, aluminum metal would be deposited immediately. Aluminum ion would be reduced and it is deposited as aluminum. Therefore, metal displacement, which metal will displace which? If you are asked, once again arrange them in their oxidation potential character. The highest would be a strong reducing agent. They will displace other metal ions from the solution present below this. Therefore, sodium can displace aluminium from aluminium 3 plus ion from aluminium, replace chromium from chromium 3 plus, replace iron 2 plus plus iron. To iron 2 plus is reduced to iron and so on. Okay, I think you follow this. In the reverse sense, which is the better oxidizing agent and the negative potential, the F2 is a stronger oxidizing agent. Oxidizes a gold to gold plus, and it is a strong oxidizing agent. Oxidizes chloride to chlorine. Oxidizes. In the partner, this is just reverse of the reduction property. We are moving from lower end to higher end. And this is the best oxidizing agent. Oxidizes all the things present above it. All the things present above it. This is the way you can easily guess which is having higher oxidation potential, which metal will be easily displacing the other metal from its salt solution, etc. can be answered looking into this one, but you have to rearrange the electrode potential in terms of the increasing, decreasing order of their oxidation potential. Any majority of the metals present in the world are placed above the hydrogen electrode potential in the electrode potential table. All of them would release hydrogen, would react with acid to release hydrogen. In other words, they would displace hydrogen from Hg plus ion because they are all strong reducing agent. And however, there are 5 metals which are present below the hydrogen electrode potential in the oxidation potential table. What are they? That's a mnemonics, CHAPA, CHAPA. And in our table, we have presented some table here, which metals are present below this hydrogen electrode, copper, silver, and gold. The copper, silver, and gold. But I have given 2 more metal ions. What are they? C for anybody? Hello.
Copper.
Copper. Next, H for
Mercury.
H for mercury. Next, A for silver. P for platinum. A for gold. These are the 5 metals which are placed below the hydrogen electrode. They won't release hydrogen by interacting with the H plus. You might have studied in your chemistry lab or in the properties of the copper. The copper will not, when you feed this with any acid, it will not release hydrogen when treated with this hydrogen, mercury, then gold, silver, platinum, and gold. Now I have given 3 metal ions, metal electrode, which are placed below the one. And what is the place or what is the electrode potential of mercury? If you understand the mnemonic chapa, you can place the mercury in between. Anybody? It is C for copper, A for silver, H should be lying in between these. Its value should be power to minus
minus
0.58. Yeah, in between mercury is present. And what is the place in which the platinum would be present? It should be in between minus 0.82 volt to minus 1.6 volt. Okay, this is the platinum. These 5 metals won't release hydrogen at all. Okay, now if you understand this one, you try to give answer for this question. Take on the question. Given.
Sir, one second.
Yeah.
சார் இதுல வந்து நம்ம ஹாலஜன்ஸ் குரூப்பையும் சேர்க்கல அயன் சேர்க்கல அது ஏன் சார் நம்மளோட
நான் வந்து பேசினது வந்து என்ன மட்டும்தான் பேசினேன், மெட்டல்ஸ் மட்டும்தான். ஹாலஜன்ஸ் எல்லாம் நான் மெட்டல்ஸ். நான் மெட்டல்ஸ் மட்டும் யார் யார் கீழே இருக்கா அப்படின்னு தான் கேட்டேன். அடுத்தது அயன் வந்து அயன் இஸ் பிரசன்ட் ஆன் த அபவ் திஸ் ஒன் இஸ் நாட் அயன். But which is present below this iron 2 plus bar iron 3 plus, don't be confused. Okay. It is not metal, metal ion is present. Here I am asking the question, which metals are placed below the hydrogen standard electrode? Do you follow this?
Okay, sir. Yes, sir.
And I take down the problems. Now try to give answer. Given epsilon naught or copper or copper 2 plus is equal to minus 0.34 volt, and epsilon iron 2 plus for iron is equal to minus 44 volt, comma, then option A, copper oxidizes iron 2 plus, B, copper 2 plus oxidizes iron, C, copper reduces Fe2 plus, D, copper 2 plus reduces Fe. It's the simplest problem. I will work out this as usual as the conventional teacher, taking the simplest problem. They work out it, and they will give you a tough problem to you as the homework or exercise. So is the case now. And whatever may be the electrode potential given, first step is convert into the oxidation potential value. They may give it in terms of oxidation potential or reduction potential value or only reduction potential value. Anything they may have given, and convert them into the oxidation potential value and arrange them in their decreasing order of the based upon the potential. Therefore, the first thing here it is given as the oxidation potential. Okay. But in the second data is reduction potential value. You know, reduction is taking place or oxidation takes place. Simply looking into this, the reactant and the product, you come to the conclusion this is oxidation or reduction. Therefore, if you change this, what would be the oxidation potential value of this? You write it as E epsilon naught of Fe for Fe2 plus. What I have told you, magnitudely they are same. இதுக்கும் என்ன வேல்யூ தான் இருக்கும் 0.44 volt, but the sign is changed, therefore it is plus. Now you have converted these two into the same oxidation potential value, then arrange them in their decreasing order of the potential, oxidation potential. Iron is having more positive value and the copper is having the negative value. This is the order. Here only two things are given. What I have told you, this iron would reduce copper 2 plus 2 copper, or the same thing can be can be revealed in another way. Iron metal, when you add to the copper 2 plus ion, copper metal would be in என்ன சொல்லுவாங்க, copper metal would be deposited. And oxidizing character, if you are asking an oxidizing character, go in the reverse manner. What do you mean by a reverse manner? Put the arrow in the reverse direction. That is, reverse direction means in this way you should put that is. Not in this way, it is wrong. Put in this way. Copper 2 plus is a strong oxidizing agent. It oxidizes iron to iron 2 plus. This is the way you can say. This way, and it gives this product. If you come this way, this and this is the product. Therefore, using this is the easiest way, you can simply tell the answer. What is the answer? Tell me the answer. Which is the correct one?
Option 2, sir.
Option 2,
Option B, sir.
yeah, copper 2 plus oxidizes iron. That is the correct answer. Now we will have another example and we will go for that example. Given the electrode potentials, zinc bar zinc 2 plus, zinc bar zinc 2 plus, electrode standard electrode potential 0.76 volt, zinc bar zinc 2 plus, magnesium bar magnesium 2 plus, magnesium for magnesium 2 plus, 2.4 volt, iron 2 plus for iron minus 0.44 volt. Which of the following statements is correct? Or sometimes they may are correct அப்படின்னு கூட சொல்லலாம். Is correct. இல்லைன்னா எப்படி கேட்கலாம்? Arrange the electrodes in the decreasing order of the oxidation potential, or arrange the electrode in the increasing order of the oxidation potential, or arrange the order in the case of their reducing character, increasing reducing character, or decreasing reducing character. Repeatedly, many number of questions can be asked, but all of them will be having the same way of answering this one, only one type of answering. Now arrange these electrodes in terms of our principle. Our principle is converted into the oxidation potential. Therefore, first thing you will write, which would be the topmost among the three, magnesium for magnesium 2 plus. Next one is zinc bar zinc 2 plus. Next one is iron bar iron 2 plus. Okay. Now, which is the strongest reducing agent? Magnesium. It will reduce which metal ions? Zinc as zinc 2 plus reduce which zinc reduce பண்ணனும் சொல்ல, but don't say that it reduces zinc. It reduces zinc 2 plus 2 zinc. It reduces iron 2 plus 2 iron. And what about the zinc? Zinc will reduce only one. யாரதான் reduce பண்ண முடியும்? Zinc will reduce iron 2 plus 2 iron. It will not reduce magnesium 2 plus 2 magnesium. Any metal would not reduce the metal ions present above its oxidation potential. Or which metal will displace which metal ion from its salt solution? Magnesium would displace zinc 2 plus zinc from zinc 2 plus. Magnesium would release iron from its iron 2 plus. Zinc can release iron from its iron 2 plus only. These are the possible answers. Now we change into oxidation, which is having among the given three, which is having highest oxidation potential or highest oxidizing character among these three. Oxidation character means if you take, they are having a reduction character. Oxidation character means you take in this way. Fe2 plus is having highest oxidizing character. Each oxidizes zinc to zinc 2 plus. Iron 2 plus would be having highest oxidizing character, which oxidizes magnesium to magnesium 2 plus. And one question, the displacement reaction, alternatively they may ask this question, whether I can place made up of zinc in a can made up of zinc. Is it possible to keep iron 2 plus ferrosulfate solution in a can made up of zinc? For which also the answer is, if you keep iron 2 plus in the zinc can, iron 2 plus will definitely react with the zinc converted into zinc 2 plus. And after a few hours, the can would be getting leaked because iron would be getting, zinc would be getting converted in zinc 2 plus, and no more zinc can would be present. Can you place iron 2 plus ion in the magnesium can? No. Can you place magnesium 2 plus ion in a zinc can? Yes. So many answers can be possible just looking into this one. Therefore, now the answer, which of the following statement is correct? Take down the options. A. Magnesium oxidizes iron. Metal will never oxidize. Metal ion would be oxidizing. Magnesium oxidizes iron. B. Zinc oxidizes iron. C. Zinc reduces iron 2 plus. D. Zinc reduces magnesium 2 plus. Which is the correct statement?
Zinc reduces iron 2 plus.
Yeah. Then another question. The same. Which is the best reducing agent?
Magnesium.
Magnesium is the best reducing agent. Which is the least reducing agent?
Iron.
Iron. Can you arrange them in the order of the reducing character, increasing order of reducing character, increasing range of the reducing character? First, write down the least one.
Iron, zinc,
Uh,
Magnesium.
Iron, zinc. Okay. Which is, can you arrange them in the order of the oxidizing, increasing oxidizing character,
Magnesium.
character of the
Zinc.
ions, character of the ions, not the metal. Iron 2 plus is having maximum oxidizing character. It oxidizes zinc and as well as magnesium. Zinc 2 plus ion is having next oxidizing character. It oxidizes magnesium to magnesium 2 plus. Now I think you understand this. I think so. Shall we move to the next application? Shall we move to the next application? The next application, the displacement of the metal from its solved solution. Displacement. அதில் ஒரு ப்ராப்ளம் பார்த்துட்டு அடுத்த அப்ளிகேஷன் போயிடும். Given the electrode potential, A, capital A, epsilon naught A2 plus bar A is equal to minus 2.1 volt B. E naught B bar B plus is equal to 1.2 volt C. Epsilon naught C plus bar C is equal to 1.76 volt. Find the correct statement from the following. Find the correct statement from the following. Option A. A oxidizes B and C. A oxidizes B and C. Option B. C displaces B from its salt solution. C displaces B from its salt solution. Option C. B would oxidize both A and C. Both A and C. Option D. A displaces B and C from their respective salt solution. From their respective salt solutions. Which is the correct answer? First, the preparatory arrangement is convert to oxidizing agents, oxidizing potential, arrange them in their decreasing. After arrangement, you can find the answer. Which is the correct answer? Anybody?
Option C.
Option
C, sir.
C.
Option 2.
Option 2. Next, option 2. C displaces B from a solved solution. Is it correct or not? First, arrange them in the oxidizing agent. First one is A க்கு வந்து என்ன வரும் 2.1 volt. Next, B bar B plus is 1.2 volt. Next is C bar C plus minus 1.76 volt. இவர்தான் கடைசியில கிடைக்காது. யாரை வெளியே தள்ளுவா அப்படின்னு நம்ம பார்த்தோம்னா A will displace B plus convert them into P. A convert the C plus into C. அவங்க கொடுத்திருக்கிறது என்ன கொடுத்திருக்கிறாங்க இப்ப பாருங்க, பார்த்துட்டு சொல்லுங்க யாரை வெளியே தள்ளுவா. ஏன்னா டிஸ்பிளேஸ்மெண்ட் தான் கேட்டிருக்காங்க. யூஸ் த ரெடியூசிங் கேரக்டர். Option D is the correct answer. And therefore you do the exercise, practice this type of question. இதுல இருந்து போனா என்ன நடக்கும், இதுல இருந்து போனா என்ன நடக்கும் அப்படின்னு பாத்தீங்கன்னா you can easily answer this. நம்ம போட்ட இந்த நெமோனிக்க போடுங்க. Displacement அப்படின்னா this to this. இவங்க இந்த ரெண்டு பேரையும் தள்ளுவாங்க. இவர் யாரை மட்டும்தான் தள்ள முடியும்? B displaces. எதை மட்டும்தான் தள்ள முடியும்? B displaces C மட்டும்தான் இருக்கும். அந்த மாதிரி ஆன்சர் எங்கேயாவது கொடுத்துருக்கிறோமா? A ஆக்சிடைசஸ் B and C கொடுத்துருக்கோம். A வந்து ஆக்சிடைஸ் பண்ணாது, என்னதான் பண்ணும்? Reduce தான் பண்ணும். Wrong answer is not. Seri, take down the question as an exercise to you. A. Copper sulfate solution can be stored in zinc vessel. Copper sulfate solution can be stored in a zinc vessel. B. Zinc sulfate solution can be stored in copper vessel. C. Copper can be displayed. Copper can be displaced by passing hydrogen through the solution. Of the above statements, which are correct? Of the above statements, which are correct? A, B, C. Our next option, A and B. C option, B and C. D option, A and C. And for this, you are need of the electrode potential. Which electrode potential you are need of it? Here, zinc electrode potential I need. Copper, it is also copper sulfate is given. Therefore, I am need of this. And the copper can be displaced by passing hydrogen. That electrode potential is also required. You know by heart, the oxidation potential of zinc bar zinc 2 plus is equal to 0.76 volt. Hydrogen bar H plus is equal to 0 volt. And copper bar copper 2 plus is equal to minus 3.4 volt. Now you can easily get the answer. என்ன நடக்கும்னு சொல்லியிருக்கோம் பாருங்க. காப்பர் சல்ஃபேட் இன் ஜிங்க் வெசல் கேன் பி கெப்ட் இருக்காங்க. காப்பர் 2 பிளஸ் ஜிங்க் வெசலில் சேர்க்க முடியுமா முடியாதா? வச்சிருக்கலாமா வச்சிருக்க கூடாதா? கேன் பி ஸ்டோர்ட் ஆர் நாட்? If you use this is oxidizing character. Copper 2 plus when stored in the zinc vessel it will react with the zinc. Zinc will be converted into zinc 2 plus, therefore it cannot be stored. But another question என்ன கொடுத்திருக்காங்க, it can be stored அப்படின்னு கொடுத்திருக்காங்க. Therefore A is a wrong answer. If you delete the A and you will get the automatically the answer. You need not to find out all the three options. This is the way you have to find out the answers. Multiple answers are given in this option. You can answer the question in this way. Take first any one of these. You can find out this. If you are lucky enough, from the first point, you will be getting your answer. Otherwise, three workout is given, any two would be sufficient to find out the correct answer. You need not to work for all the three. Similarly, if four workouts are given and you find out the correct answer, any two would be sufficient. You will take, definitely you will arrive at the answer. Don't waste the time in working out all the four. Therefore, in this way, now we have seen that our answer has been, we are lucky enough. Okay, this is the first application of this electrode potential, and you are going to see the second application. The second application of the electrode potential. It is possible to take down the second second application. It is possible to construct a voltaic cell. To construct a voltaic cell. And after constructing the voltaic cell, we can find out the potential of the cell or the voltage of the cell or the electromotive force. Why we call it as the EMF? We will tell why we call it as the EMF. EMF is the same, cell potential is the same, or voltage is the same. Therefore, we can call it as the cell potential or voltage of the cell or the EMF of the cell. They are referring to one and the same. And the unit for this is once again the voltage, because we are calculating it from the electrode potential, which are having the unit volt. Therefore, E naught is also having volt. Now construct a voltaic cell. We have already seen for constructing a cell, two electrodes are necessary, of which one would be the anode, another would be the cathode. What is anode? Anode is one from which electron is passing towards the cathode. From which electrode you can be acting as the anode, which would be the cathode. After constructing this, so many questions can be asked. Electron is moving from which to which? The last day we have discussion that one. In which case the electrode loss would be there, in which case the electrode weight is increased. And the cation, whether there is a movement of cation and anion. If cation movement is there, from which ion compartment to which compartment, and that compartment to compartment, and what is the net potential for this, and so many questions can be asked. And now I am going to give some, explain this in terms of some examples which can be constructed as this one and which can be constructed as one. I am not going to give this electrode. Instead of giving this electrode, I am giving it in terms of the A and the B. Take down the question. Given the electrodes, A bar A minus is equal to A plus, not A minus, equal to minus 0.21 volt. B, next to B minus for P2 minus equal to 1.21 volt. C minus bar C3 minus equal to minus 1.25 volt. D bar D minus 2 minus equal to 0.52 volt. First question, how many cells can be constructed using these 4 electrodes? How many cells can be constructed using these 4 electrodes? Second question, which combination of electrodes will give a shell with the highest EMF? Which combination of the cell will give you the highest EMF? And the third one, which combination of the shell will give the lowest EMF? The lowest EMF. Second, for the second question, take the option A and B combination, B and C combination, C and D combination, D, A and D combination. This is the choice given for which combination of the electrodes will give you a cell with the highest EMF. And for the third question, which combination would give you the least EMF shell? Oh, that is not, I have not prepared this one. Okay, for which we will calculate it. Next, first answer, how to find out how many electrodes are given. Using this electrode, how many numbers of cells can be constructed. Before seeing the formula for this, first we will arrange our electrodes according to our principle, convert them into the oxidation potential and arrange them in their decreasing oxidation potential. First here it is given, are all oxidation potential value or reduction potential value? What about the A electrode? It is the oxidation potential, is not? And anybody tell me, what about the second one? Oxidation or reduction potential?
Reduction.
Therefore, here it is converted into the oxidation potential will equal to minus 1.21 volt. The C electrode reduction convert into the oxidation potential will 1.25 volt. Then the last one,
Reduction potential.
therefore convert into oxidation potential minus 0.5. We have converted all the 4 into the oxidation potential value. Next task is to arrange in the order, in the decreasing order of the potential. The first one is, tell me the first one, C3 minus or
2C
C minus equal to
1.25.
1.25. Then
A to A plus
A bar A plus is equal to minus 0.21 volt. Next, D 2 minus bar D is equal to minus 0.52. Next, last is B 2 minus bar B minus is equal to minus 1.21 volt. And of this, which can be used as the anode, which electrode can be used as the cathode. After charting out the electrodes in terms of their oxidation potential, decreasing oxidation potential, we can immediately say the one with the higher oxidation potential, that is plus value higher. Among these two electrodes are necessary for constructing a cell. Of the 2 electrodes, which is having highest oxidation potential value, it would be always acting as the anode. The other would be acting as the cathode. This is the simplest rule. Therefore, among C and A electrode, which would be acting as the anode, which would be acting as the cathode, the C is the acting as the anode, and A is the acting as the cathode. Okay, do you follow this? Similarly, the A can be acting as the anode, and D bar can be acting as a cathode. Because of these two combination, C is having higher oxidation potential. Therefore, of these two, this one. Among these two, C and B, definitely C would be acting as an anode only, and B as the cathode only. Okay. Therefore, with the C, now you have constructed three electrodes: C with A, C with D, C with B. Three electrodes have been constructed. Now we go for, after finding out the possibility for C, now you take the possibility with the other one. Now among the three, which would be having highest oxidation potential of these two? A is having the higher. Therefore, with this A, how many possibilities can be used?
Two.
A and D, A and B. Therefore, two. Then after eliminating this A, the remaining one is there. Therefore, how many total cells can be constructed?
6.
6. This number can be calculated using the formula. How many electrodes are there? And C, 2. What is then, how do you call it? 4C2 combination with formula, that is 4 factorial, that is equal to 4 factorial by the C2 factorial. The following is 4 minus 2 factorial. 4 to power 4 factorial, 2 factorial, and 2 factorial. What is the answer? What is the answer?
6, sir.
Yeah, that is the correct one. In our table, we have given almost 18 electrode, I think so. Making use of this 18 electrode, how many number of cells, voltaic cells can be constructed? That is available, but required for constructing a cell, finding the various combinations, 18C to find the way. This is the way you can find out. You can find out the number of cells possible using the number of electrodes given. This is the first thing you have given answer. Second thing is which combination of the electrodes will give you the highest EMF. The highest EMF. Here you have to calculate the EMF for this. I will take one thing and C3 minus and C minus as the anode because it is an anode. And then next one is D2 minus for D. It's a cathode 0.52, anode and cathode, and the E0 is given by anode. Epsilon 0 of the anode. Anode oxidation is taking place. 3 minus for C. And here we have written as the oxidation, but in the cathode, it is a cathode. The cathode reduction would be taking place. Instead of the oxidation potential, convert into the reduction potential and summing up this one, D bar D2 minus. Here note this is a reduction potential. This is the oxidation potential. If you use the reduction potential as such, then find the difference between the two oxidation potential. If you convert into a reduction potential, sum of the oxidation potential value and the reduction potential. Both of them will give you the same value. This E0, C0 is equal to value is 1.25 and D for D plus is plus 0.52. Therefore equal to 1.77 volt. Therefore, here we have calculated the potential difference And what is the difference between 1.25 and minus 0.52 by mental sum? You can calculate this. What is the difference between this 1.25 minus of minus 0.52? It is equal to 1.77. Now, tell me what would be the E naught for the first two combinations, C electrode and A electrode. What would be the value? Anybody immediately tell without writing and doing the problem.
1.46.
1.6. What would be the relationship between? What is the E naught between E0 between the combination of the electrodes C and B?
2.46.
2.46. Now, from the value you can tell which would give you the highest EMF, which combination would give you the highest EMF. Anybody tell me?
C and B.
C and B, sir.
The highest in the oxidation potential value and the lowest potential will definitely give the highest EMF. You can't go and do the problem just looking into this. These two would give you the highest EMF. Therefore, among the combination given, which would give you, which electrode combination would give you the highest EMF? A and B, or B and C, or C and D, and A and D, which is the correct answer? Hello? Hello?
B,
No
sir.
voice.
Option B. B and C.
B and C combination would give you the highest. And the next question is, which would give you the lowest EMF share? Which two potential is having very nearest potential of the four? Which two is having nearest
A and D.
potential? A and D, it is having very nearest potential, definitely they would give you the least EMF. In this way, now you are not working out the problems, just looking into the values. You can say this would give you this one. Or can you arrange this combination of these six voltaic cells in the increasing way of giving the cell voltage? Cell voltage increasing order, can you arrange them? You can definitely give the answer. You can definitely give the answer. Okay. In this way, this is the second applications. And now I am going to give you another applications in this one. After seeing this, we will go for the third applications. And in the same one, construction of the cells. The next one, but no question is so far asked. If at all asked, you should not be confused. First, we will see what are the possible combination of the shells, anode and cathode. Anode and cathode. Here in the table, I have given the metals at the top, hydrogen, then some metals here, and the non-metals. Non-metals. What are the possible common? And here the metal, the topper in the metal is the lithium bar, lithium 2 plus, is not lithium plus. And the lowest is the iron, fluoride bar, fluorine. And this would always, the lithium bar, lithium plus would be always acting as the anode. It cannot be changed into a cathode because அவருக்கு மேல யாருமே கிடையாது. Therefore, lithium bar, lithium plus would be always acting as the anode. Similarly, the lowest fluoride for fluorine, it will always acting as the cathode. The highest oxidation potential would anode, the lowest oxidation potential value would be the cathode, and these two will never change its electrode nature. But in between cases, they would be acting as the anode or cathode. Sir, I am not following this. Anybody can ask. For example, now I will tell you one thing. Aluminium bar, aluminium 3 plus. Its electrode potential is 1.66 volt. Then another is magnesium bar, magnesium 2 plus. Its potential value is 2.3 volt. Then next iron bar, iron 2 plus. Its potential is 0.44 volt. Of this, if you now consider these two, one which would be the anode, which would be the cathode, definitely the higher potential would be the anode, the next one is the cathode. Now if you compare these two, one, now which is the anode, which is the cathode? Aluminum is the anode, iron would be the cathode, is not? Therefore, the intermediate electrode may be acting as the anode or cathode depending upon the nature of the other electrode. But the topper and the bottom, they won't change their nature. They would be remaining as the anode and cathode. Making use of this, one question is asked, but so far this question is asked because it is, we think it is below your standard in CSR examination. Take down that question. Which of the following electrodes cannot act as either cathode or anode of a shell, depending on the nature of other electrodes? Depending on the nature of the other electrode. Option A, F minus for F2, comma, sodium or sodium plus. Option B, MnO4 minus for Mn2 plus, bar lithium plus. C, fluoride bar fluorine, lithium bar lithium plus. D option, MnO4 minus for Mn2 plus, sodium bar sodium plus. Read the question and tell me the answer.
Option D, sir.
Option?
Option D, sir. MnO4 minus Mn2 plus and sodium plus.
What is asked? Once again, read the question. Which of the following electrodes cannot act as either cathode or anode? Cathode act pannade, anode agadu of a shell, depending on the nature of the other electrode. If other electrodes are present, it will change the nature. It will change either cathode or anode. அப்படி இல்லாத electrodes யாரு? Which will not change their character, which cannot act as either
C, sir.
option C. அவங்க எப்பயுமே fluoride would be always acting as the cathode, and lithium would always act as a cathode. Intermediate all electrodes will be change the nature of the electrode nature. It may be acting as anode or cathode depending upon other electrodes present. It is a simplest question asked. Okay. And anode and cathode, one thing I want to tell this one. What is that one? Other than this one. Another questions I am going to give this one. Anode and cathode. What are the possible combination of metal and in the list metals are there, hydrogen atoms are there. Some metals are present below the hydrogen, and then non-metals are present. Possible combinations are metal would be acting as the anode and hydrogen would be acting as the cathode. This is the one combination, is not? Metal and hydrogen. அதுக்கு முன்னால one metal would be acting as the anode, another metal would be acting as the cathode. இதுக்கு ஊடால metals are there, therefore this type of combination we call metal cells அப்படின்னு சொல்லுவோம், or metal combination cells. That is one metal in the cathode, one metal is the anode, metal shells. The next possible combination is metal as the anode and hydrogen as the cathode. Hydrogen as the cathode. Another possible combination is metal and non-metals. Metals and metal as the anode, and definitely non-metals would be the cathode. And another combination is இதெல்லாம் பார்த்துட்டோம்னு நினைக்கிறேன். The metal 3 possibilities are there, எல்லாமே ruled out. Then we will take hydrogen. What are the possibility for the hydrogen would be acting as the anode, and some metals would be acting as the cathode. Which metal would be acting as the cathode? If hydrogen is the anode, we have already seen the copper would be acting as the cathode and hydrogen is the anode. But all other things, metal would be acting as the anode. This question may be asked. When hydrogen is acting as the anode, is any metal would be, electrode would be there which is acting as the cathode? Can you give answer? Yes, there are 5 metals are there. They would definitely acting as the cathode. Okay. Therefore, this is another combination. Then hydrogen and non-metals. Hydrogen and non-metals. And there is a one important one. A non-metal and metal combination is there. A non-metal is acting as the anode and a metal is acting as a cathode. It's the rarest combination. Can you give me an example for this? I have given it in your table. Look at the table. Give me the combination for this non-metal and metal. Non-metal and metal. Non-metal as anode and metal as the cathode. Anybody?
Iodine and iron.
Iodine and iron. No, iron is not a metal there. Iron 2 plus and iron 4, 3 plus. I am asking metal. Iodine, right? Iodine is the anode.
Sir, iodine with silver or gold.
Yeah, silver or gold. அயனுக்கு கீழே இருக்கிறவங்க, அயோடினுக்கு கீழே இருக்கிறவங்க எல்லாம் யார் இருக்கா? சில்வர் இருக்காரு, பிளாட்டினம் இருக்காரு, கோல்டு இருக்காரு. They will form definitely which type of combination? Non-metal metal combination shells can be there. இது வரைக்கும் so far no question is asked, but it is possible to ask question. Which of the possible? They will give you silver bar silver plus and hydrogen bar H plus. This is a combination of metal hydrogen combination, electrode combination, or hydrogen non-metal electrode combination. And which here hydrogen would be acting as the anode and the silver would be acting as the cathode. This combination, just this is a survey. You are searching for anything is important by looking into the table. We are surveying it. Questions may not be asked or may not be asked, but it will be very useful for you at any of the time. Therefore, these are the possible combinations. How many combinations are there? 3, 2, and 1. And the one last combination is non-metal combination. Non-metal as the anode and the non-metal as the cathode. You can take it the iodine and bromine, iodine and chlorine, iodine and fluorine, non-metal and non-metal. These are the possible 7 possibilities. And why I am going to give this one is, but no question is so far asked, and now I am going to give that question, and then I will going to give the answer for this. Take down the question. Take down the question. The net reaction of a shell. the net reaction of a shell is given as A plus B minus giving A plus B. A plus B minus giving us A plus B. The cell is due to the combination of இப்போ சொன்னோம் பார்த்தீங்களா, how many combinations we have given? 7 combinations. 7 combinationையும் நீங்க எழுதலாம். ஆனா எத்தனை தான் கொடுத்திருப்பாங்க? 4 options. Here 7 combinations. First combination, these 4. பாருங்க, இதையும் பார்த்து மொத்தம் 4 combination. எல்லாமே ஒரே வகையை சேர்ந்தது. And these 2 combination, and this is alone is belonging. 3 types of the cell reactions would be I am going to give, of which one would be A plus B minus giving A plus B, and another is an atom or irkalam, the reactant side atom or molecule, a neutral atom or neutral molecule, plus one ion would be present. Here in this, the anions consisting of only anion reactants consisting of the ions only, A plus, B minus, or A plus and B plus, anything may be there. Yeah, but they consisting of ions only. But another combination is there in which a neutral and the ion is present. And another combination is there atoms, that is a molecule, neutral combination, plus another reactant would be definitely there. It is also a neutral. These are the 3 possibilities present in a net cell reactions. Now our question is, this possibility is due to what? This possibility is due to what? This possibility is due to what? I have given you, these 4 would give you same type of the net reaction. These 2 would give you the same type of net reaction. This one alone will give another type of the net reaction, and which is belonging to which is equal to which we are going to see. First, we will take the metal combination. The metal combination, we will take a specific example: zinc 2 plus and the copper 2 plus for copper. And this cell we are, if you put a salt bridge, it is called a voltaic cell. And instead of this, we put it is a perforated part. We call this Daniel's shell. In the Daniel's cell, salt bridge is not used. Instead, it will be consisting of the porous part. We call it as the Daniel's cell. Here, this we should write down the anode, first anode reaction. Anode is taking oxidation. First, the anode half reaction we have written as zinc and zinc 2 plus 2 electron. And we are writing the cathode reaction, copper 2 plus wood, and taking the 2 electron forming the copper. And the net reaction, for which we have already balanced this electron would be cancelled. Otherwise, multiply the equation and add such that the electron should be cancelled. And the net reaction is zinc and copper 2 plus, giving zinc 2 plus and copper. Okay. In this, find out what is this. One is in the atomic state neutral, and another is the ion. Therefore, this combination, metal combination, would give this type of net reaction. And looking into this combination, you can immediately say this. What I have told you, this is the reactant, this is the product. This is the reactant, this is the product. Therefore, you can immediately write zinc plus copper 2 plus. Reactants, we have written the reactants inside. And the other side, we are writing the products, zinc 2 plus copper. It is a neutral atom and an ion. Therefore, it is belonging to this. Similarly, what about the metal hydrogen electrode? Tell me the metal hydrogen electrode. which would be taking place. Anybody, immediately you can say this, metal hydrogen electrode. நானே போட்டு கொடுத்துட்டேன். They all the four would give you like this சொல்லிட்டேன். எங்க சொல்லுங்க பார்க்கலாம். சொல்லுங்க பார்க்கலாம். Metal and this one. Say metal hydrogen, zinc bar zinc 2 plus. And hydrogen is acting as the anode. Therefore, H plus for H2 plus, H2. Now, what are present in the reactant side? Zinc plus, H plus, neutral atom, and an ion is present. Therefore, that combination, metal hydrogen is also belonging to this, the neutral atom plus ion. And another combination I have given is hydrogen and metal. Example for this is here, hydrogen is present as H2 bar H plus 0 and copper 2 plus bar copper minus 0.34 அப்படின்னு படிச்சிருப்பீங்க. In this combination, what is this? Net reaction would involve a neutral molecule and the ion. The neutral molecule and the ion. And the last thing is a non-metal combination. Non-metal combination. In the non-metal combination, if you go for this, definitely, for example, non-metal combination, iodide bar iodine. And the iodide bar iodine is the anode. And let us take chlorine. This is having its potential is minus, tell me, its potential is iodide bar iodine potential. Minus 0.54 volt. And chlorine, chloride bar chlorine, it is minus 1.34, I think so, minus 3. Of this, which is more oxidation potential, this is more oxidation potential, this is less oxidation potential. Therefore, we will write it as the anode. Anode means oxidation. And it should be converted into cathode. Cathode means reduction. Okay. Now, in the reaction side, what are present? An ion and the molecule is present. Therefore, non-metal also having ion and molecule in the net reaction side. Therefore, all the four combination would give you, if you at all given, if anybody asks you to give that is a molecule plus an ion is present in the reactant side. Say example, A2 plus X minus is there. What is X minus mudapodama D minus and products is there. இது யாரா இருக்கலாம் சொல்லுங்க அப்படின்னா two combinations. One is என்ன இருக்கும்? Metal combination definitely not present because metal is present. It is forming an atom only. Here molecule means metal hydrogen combination or non-metal combination or hydrogen metal combination. These three would be having this one. And atom and ions are present. Definitely you can say it is a metal combination and metal non-metal combination. Sorry, metal non-metal. It is a non-metal combination or metal combination. You can easily say like that. Then another combination we are going to see, the hydrogen non-metal combination. Hydrogen non-metal combination. What is the thing we have taken? Hydrogen non-metal combination. For hydrogen, H2 and H plus, 0 volt, non-metal, iodide bar, iodine, minus 0.54 volt. And definitely this is the cathode, and this, this is the anode, and this is the cathode. And after writing this, you are going to calculate the E of the cell. That can be, you can write as epsilon 0 H2 bar H plus. Anode oxidation should be taking place. Plus epsilon, it is a cathode. Cathode reduction should be taking place. Therefore, change this. We have written as the oxidation reaction, change into reduction. For oxidation, it is 0. For reduction, change the sign and equal magnitude. The net cell is what is 0.54 volt. What is the net reactions for this? What is this? Is the reactant. This is the reactant. These two are the product. Immediately you can write H2 plus I2 giving H plus I minus. Balance these 2H plus 2 net. This is the net reaction. How many electrons are involved? 2 electrons would be definitely there because 2H plus and 2I minus, 2 electrons are involved in the reaction. Here, if you look out in the reactant side, here both of them are the neutral species are present. Therefore, in the combination of hydrogen and non-metal, definitely there is both of the reactants are என்னவாத்தான் இருக்கணும் hydrogen and non-metal இருக்கணும். And there is one more thing, that is metal and non-metal combination. I have told you metal and non-metal combination. For example, aluminium or aluminium 3 plus, it is 1.66 volt. Any metal you can take it. And iodine, iodide or iodine, oxidation potential, minus 0.54 volt. Therefore, which should be acting as the anode, which should be acting as the cathode? Aluminium or aluminium 3 plus is the anode, and oxidation should be taking place, epsilon 0. And which should be taking place in the cathode? Oxidation. Here we have written, reduction. Here we return is oxidation, just to change it, reduction. This value is 1.66 volt. What is the value? Just to change the sign and write down the value. And this is the shell potential. Okay. The shell potential or cell voltage. It is also this much amount of this potential is required to move the electron from aluminium to iodine. This much amount of potential is required. Therefore, that potential we call the electron moving potential or electromotive potential. Therefore, we call it as the EMF. This much amount of potential is required to move the electron from this and this. It is also called electromotive force. And here, what would be the net reaction? Aluminium reactant side here, which would be the reactant side? Iodine. In the product side, aluminium 3 plus and iodide minus. Balance this reaction in such a way that here the number of electrons involved here should be the same. Here first to balance the species first, as I have told you, species, and how many electrons are released. 3 plus electrons and 2 minus is there. And here the 3 plus should be multiplied by 2, and the minus 2 minus should be multiplied by the 3. Here, if you write this aluminum species should be multiplied by 2, and this iodine species should be multiplied by 6. There should be 6 iodine multiplied. Therefore, it will be converted to 2, and 6 iodine, already 2 is there, 3 iodine, and it is now converted into 6. And 2 aluminium. How many electrons are involved? 6 electrons are involved in the process. In this way also you can easily balance this. Either step-by-step balance or direct balancing is there. Here also, if you come across the reactant side, only neutral species are present. And finally, the last one, what I have told you is that non-metal and a metal. The non-metal and a non-metal is, example is iodine, iodide bar iodine oxidation potential is minus 0.54 volt, and the combination you have told is silver for silver plus or gold for gold plus, it is minus 0.8 volt. Of these two, which is having higher potential, this iodide, therefore anode is the iodine minus I2. Oxidation, here it is oxidation is not plus. This should be acting as the cathode, epsilon 0, Cathode means a reduction should be taking place. This one. What would be the potential value for the cell constructed? It is minus 0.54 and change this one plus 0.8 and the value is 0.26 volt. And what would be the net reaction? I minus reactant side, Ag plus reactant side, giving iodine in the product side and silver. Here, balance this 2I minus. And here, 2 charge balance the charge. This will be 2 Ag plus and automatically it is 2 Ag. Look at this. Here, the species present in the reactant side are all ions. Now, tell me the answer for the given problem. The net reaction of the cell is given as A plus and B minus, giving A plus B. The cell is due to the combination of what? And tell me the answer. Combination of what? Non-metal, metal electrode. But this type of questions is not so far asked. But if at all appearing, you can tell me easily tell the answer for this. Therefore, have an exercise over this. And we are going to see the fourth application, I think. So first one, second cell construction, third applications. And what is the third application? It's an important application. The third application is the third applications you are going to do the work done by the cells. What is the work done by the cells? The thermodynamics, you have work done by the system, work done by the system on the surrounding, or work done on the system, etc. Here, electricity is produced. Therefore, which is working? The cell is working to release electricity. Therefore, it is doing some work. The work is done by the system on the surrounding. Whenever work is done by the system, it is said to be the minus W. Work W for work, it is given in Joule. Given in Joule, the value is larger, it is converted into kilojoule because work is done by the cell, therefore minus W. And work is done by the system means which process should be taking place in the shell? A spontaneous process should be taking place. If the spontaneous process is taking place in the thermodynamics, you have studied the change in the potential, keeps the energy, delta G is a measure of the maximum useful work extracted from the process, maximum work extracted. Therefore, delta G would be called as the W max. Therefore, what is the work done by the system? And here the work is done by, work is done by the system. Therefore, we will put this as a delta minus delta G is the work done by this one. Or minus W max in total. And what is the work done by the system? That is, it is converting. For the one electron release, so much potential is equal. E not volt is required. How many electrons are, so much electrons are released? N number of electrons would be released. For zinc, 2 electrons are involving. If aluminum is involving, 3 electrons. In the previous equation, we see 6 electrons are involved and so on. Therefore, if you multiply the N into E naught, it is the work done for the one species, for aluminium, releasing aluminum 3 plus and 3 electrons. What is the work done by the system? 3 into, for the 1 electron release, this is a 3E0 volt. We will call it as. This is for the one atom species is there. But if you convert this into delta G, it is the energy change per mole, 1 mole. Therefore, this should be converted. This work is for the release of 3 electrons for the release of 1 mole of the coulombs or 1 mole of electrons, 1 mole of electrons. That is the Avogadro number of electrons released. How much amount of energy is released? That we call it as the free energy chain. Therefore, for this, how many coulombs are there for 1 mole of electron? For 1 mole of electron, why we are in need of the coulombs? N is a number, E is the volt. Volt is nothing but what can be replaced by joule per coulomb. Okay. Now delta G is given in terms of joule per mole. This is joule per coulomb. Therefore, you have to calculate for 1 mole of electron, how much is the coulombs? How many coulombs are there? Any charge, whether positive or negative charge, the charge present according to the SI unit is equal to 1.6 into 10 to the power of minus 90 coulombs charge is present. You have studied. Therefore, for one electron or one positive charge, for 1 mole of electron, you have to multiply it by 6.023 into 10 to the power of 23. If you multiply it, you will get 96,475 coulombs. We convert it to 96,500 coulombs. That is equal to 1 Faraday. Therefore, convert into the from 3 electrons to into the 1 mole of electrons. You have to multiply it with NFE naught. Now you are multiplying with the so many coulombs, that coulombs and would be cancelled, and you will get the joule, and it is minus maximum work done is nothing but NFE naught, and the maximum work done is equal to minus delta G, or delta G is equal to minus NFE naught. This is the equation we are going to use. While we calculate the maximum work done by the cell means you have to sufficient to calculate NFE naught. It will be, what is the unit for this? Unit for this is a joule, energy unit. And this is for per mole. Voltage for 1 coulomb charge. Now we are converting into the joule. Therefore, you are multiplying with the this type of theoretical work mostly done by Nance, the Walter Nast. He have derived so many number of derived equations in the electrochemistry. One famous equation is the Nernst equation. We are going to solve this since we are using the standard electrode potential. The delta G we observed is also the standard free energy chain. You should call it as a standard free energy chain. If you want to calculate the potential in non-standard condition, then the potential is referred as a E. If you calculate E, then the free energy change is calculated in terms of delta G. How to calculate E? For the calculation, we are making use of the Nernst equation. After completing some problems in this section, we will go for that calculation by Nernst equation. Now, we are correlating delta G is equal to minus NF E naught. And delta G is negative. It's indicating spontaneous process. When delta G would be negative, E naught should be positive. Therefore, from the starting, in the starting of this electrochemistry, I have given you for the spontaneous process, delta H is negative, so delta G is negative because delta G and delta H are related to each other as delta G is equal to delta H minus T delta S. But delta H is not used as a criterion for the spontaneity of a reaction, only delta G, because delta H is in addition involves the delta S value. Therefore, it will not be used as a criterion for predicting the spontaneity. And E should be a positive value, then it is a spontaneous. I have told this. And thermodynamics is an island in chemistry, and this electrochemistry is another island. If you want to convert the electrochemistry parameter into a thermodynamic parameter or a thermodynamic parameter into a electrochemical parameter, you should pass through this passage, through this bridge. What is the bridge which is connecting the thermodynamics and electrochemistry? That is nothing but delta G is equal to minus NF E0. Once you have given E0, you can find out the delta G. When delta G is observed, you can calculate delta H0. If you know the delta H0, you can calculate delta S0. And what are other parameters related to them can be calculated. But how can you pass from the E0 to this? Only through this equation. Therefore, we generally call this delta G is equal to minus N of E0 is a bridge between the thermodynamics and electrochemistry. Similarly, problems may be given. Delta H for the net chemical reaction taking place, the net chemical reaction of the shell papatome, they may give the G0 for the formation of each and everything. From this, you can find out the E naught of the cell, they may be given. G0 is given. Therefore, you should go by this bridge, through this bridge, delta G is equal to minus N, for which you are need of delta G0. You can calculate delta G0 by making use of the thermochemistry. That is G0 of the products minus G0 of the reactant, from which delta G0 you can calculate. And from this delta G0, you know F is a Faraday constant, and N is the number of electrons involved in the process. And E naught can be easily calculated. Or if E naught is given, what would be the delta H naught involved in the process? What is the heat change in the process? Once again, you should go through this. First, to find out delta G naught, and delta G naught is given. Delta G naught, delta H naught, and the delta S naught, the entropy change. If entropy change is given, this is you have calculated. This is given, the temperature is given. You can calculate delta H0. Therefore, so many thermodynamic properties can be calculated using these. And for our calculation, for our CSIR examination, calculate the maximum energy, what is the maximum work done by the system. Analyze this equation, delta G naught is equal to minus NF E naught. Analyze this equation. This is a unknown parameter. N, depending upon the net chemical reaction, N may be changed. F, Faraday of electricity is a constant. Therefore, they won't ask this in question. And E naught is the EMF of the shell, standard EMF of the shell. Depending upon the delta G and N, the value is going to be changed. Therefore, three types of problems may be asked in this. They may give this Z naught and N, they won't give you directly. They would give you the net reaction that is taking place. You have to calculate number of electrons involved in that process. How to calculate the number of electrons involved in the process? I will tell the way in which from which you can calculate delta G. Sometimes you may be asked to calculate the temperature coefficient of the EMF. What do you mean by temperature coefficient? We have told you that the electrode potential depends upon the temperature. Therefore, we have predicted the standard condition, 25 degrees centigrade. If either temperature is increase or decrease, accordingly the EMF would be changed or electrode potential would be changed. If EMF is changed, if E0 is equal to some values at one temperature, E0 is some value at another temperature. The temperature coefficient is given by delta E1 and E2 divided by delta T, that is T2 and D1, difference in this delta. This we call as the temperature coefficient. The temperature coefficient is given. Delta S can be calculated. Delta S is equal to, take down this problem. N, not this formula. NF is equal to delta E by delta tau T, tau E by tau T at constant pressure. The tau E by tau T is called the temperature coefficient. They would give you the temperature coefficient. You can calculate what is the entropy change. If E naught is given, then it is, if it is a E naught is given, then it is a delta naught. If E is given, it is called the delta S. Therefore, this parameter can be calculated. And the delta H, the another parameter, I will give you the formula and the problems may be worked out in the next class. The delta H or delta H naught, anything, both of them would be having the same one, is given by the equation NFT into dou E naught and dou E naught by dou T at constant pressure minus NF E naught. NF E naught. This is for the cell EMF. Similar equation can be calculated for the electrode potential reaction. For this, instead of E, you should put epsilon. That's the only difference. Instead of E, you should put epsilon. Okay. Therefore, no separate equations are there. The delta H naught can be calculated. Or delta H is called to be calculated means instead of naught, you should simply put E and E. For the electrode, if you want to calculate, instead of E, you should put epsilon. So accordingly, you can change this one. Therefore, if you calculate delta G, what are the parameters that can be calculated? Delta G, delta H, delta S, all of them can be calculated. And we will work out some problems first with this one. And another the important thing I have forgotten to give. If delta G naught is given, delta G is equal to minus RT ln. Where K is called the equilibrium constant. The equilibrium constant value, the problem will be frequently asked in this. You can rearrange this. Delta G naught is equal to minus RT by 2.3 naught, sorry, minus 2.303 into RT into log K. Is not. But delta G naught is equal to nothing but minus NF E naught equal to this much. Or log K would be equal to this minus and that minus gets cancelled. NF E naught divided by 2.3 into R into T. Okay. Do you follow this? And here, n, the number of electrons involved in the process is going on changing. E naught, it is also going to be changed. F, F is the Faraday. And the Faraday is a constant. It is equal to 96,500 coulombs. Okay. And 2.3 is a constant. T is a constant. R is a constant. Here the R should be R should be given in terms of the joule, 8.314 joule, and temperature in degree Kelvin. In the standard condition, we will put the temperature is 298. Therefore, put this constant into this one, that is 96,500 divided by 2.3 into 8.314 into 298. All of the value would be equal to 0.0592. Therefore, we simplify in the standard condition as 0.0592 into, sorry, once again I am sorry, it is in the numerator, denominator, Ne naught by 0.0592. Sorry, just to invert this, you will get this value. Yeah, this value. Therefore, in our calculation, we simplify it into Ne naught by 0.06. And K value is the anti-log of this. Anti-log means 10 power N E naught by 0.06. Therefore, you can calculate the equilibrium constant, provided if you know the number of electron and E naught, you need not to derive all these things. Therefore, it is sufficient to have this one. And then keep it in your mind. And the next session, I will work out some problem in this one. And with that, we will finish with the Nernst equation. We will finish this session, then go for the concentration shell and liquid junction potential. Okay, thank you, dear participants, and have a nice day.